So this is page 27 through 29. And again, this is starting our new chapter of solving systems of equations. So our first system was x plus y equals 4 and 2x minus y equals 5. Did anyone happen to get to the end? First of all, did anybody choose to do the first page? A. Okay. Did we get any solution? Did we get a place? Well, what would that solution look like? Say it again. A coordinate, a point, right? So the solution probably could be a point. It might be the entire line if one line is exactly the same as the other, right? Or the solution might be the null set or nothing if they are parallel lines, right? Because then there would be no solution. So we have 3 different solution types. Did anyone happen to get a solution for this first system of equations? Did they intersect? Did anybody do the graphing part? Anyone? Did anybody get an answer by substitution? What did you get for that? Negative 2.5, and did you get a y value? Anybody do the substitution? What did you get?
Yeah, I got the
Negative what? Negative 4. So negative 2.5 and negative 4. Okay. Anybody else? Andrew, which one did you do? A, B, or C? 27, 28, or 29? Or which did you start on? You got it wrong? I don't know that these are right because as I look at these, if this is the x and the y and I substitute these back in, is negative 2.5 plus negative 4, does that give me a positive 4? It does not. So you did A, you did A, you did A. Anybody else do A? Everybody's like, oh, it's the first one. Let's do A. Did you get any values? No. Herlin, did you get any values? What did you get, LaShawn? 1 and what? 1 and 3. Okay, so let's back this up a little bit. So let's try 1 and 3 and see if I substitute those in. 1 plus 3 is 4. 2 times 1 is 2. Minus 3 is not 5. All right. And I don't have this, so let's see. Substitution. I'm going to do substitution. This is page 27. Those of you, even if you did not do A, let's all do this on page 27, the substitution method, okay? Y equals 4x plus 6 and 2x minus 3y equals 7. So everybody, we're on page 27. We're doing the substitution method. Okay? Because we're not seeming to get the right answer here. Substitution means you are always looking for x equals something or y equals something, right? Because we want to substitute that one variable in for the other one. Yes. They are in the back. Yes. So here I have y is equal to all of this. So I'm going to substitute all of that in place of my y in the second equation. So I get 2 times x minus 3 times my y value of 4x plus 6 equals 7. All right, so I get 2x. Now, this is what some of you might not have done. You have to take that as a -3 and distribute that as a -3. I'm not sure if you did that. Okay. So that is going to be a -12x minus 18 equals 7. Okay. So 2x minus 12x, that would give me -10x minus 18 equals 7. I'm trying to solve for my x value here, so I would add 18, add 18. I get -10x is equal to 25. Yeah, this is kind of looking like x equals -2.5. Okay, so maybe we did get the x value correct. A couple of you. So now I need to substitute that in place of one of my x amounts. And yeah, go exactly. Because I'm trying to solve for y, I've got y set up by itself. So y equals 4 times my x value of -2.5 plus 6. Y is equal to -2.5 times 4 is going to be -10 plus 6. Y equals -4. That's weird. Isn't that what you said? That is really wonky. X is -2.5, y is -4, but if we go back over here, x -2.5, y is -4. That doesn't seem to work. If x is down here, -4.5. Okay, something is wrong in the state of Denmark. Huh? That is very bizarre.
System 1.
Say that again.
You have it over where it says system 1.
Yeah.
Here's over system 2 or something. I think you might be looking at the wrong one.
Oh, right. Substitution method. Okay. Yes, I think that is it. So, thank you. I was about to lose my mind. So, this actually is system 2. So,
Because the system 1 is the graphic.
gotcha. So, -2.5 and y is -4, which means what you were saying about 1 and 3, but 1 and 3 didn't quite work for the second one. Right, LaShawn? Okay, so let's take a look. 4 times that is -10 plus 6 is -4. That works out. 2 times that is -5 plus 12 is 7. So yes. Okay. Whew. For that system 2, which is, I guess, the second set of equations, which method do you think, if we left them as this, would be the best way to do that? Should we graph them? Should we use substitution? Or would elimination be the best there? What would be the preferred method for this system of equations here? Yeah, substitution. Who said that? Under your breath? Yeah, I was like, substitution? Yes, because you already have y equals. So substitution is going to be the best here because you have y equals already for the first equation. Okay. So did you do, LaShawn, did you do system 1, x plus y equals 4, 2x minus y equals 5? Is that the one you were working on? Because I thought we were working on it, but we were actually working on the second. And did you still come up with just 1 and 3? You worked on A. I think most people worked on A. Kaylee, which one did you work on, if any? A? And you were working on B? Did you get any answers for B?
First, the substitution, yeah, I got x equal 1, and then y equals 2.
1 and 3. And that was for the equation 3x plus 2y equals 8?
No, that's for the substitution.
Okay, but for what's the equation?
Oh,
X plus y equals 4?
yes.
And 2x minus y equals 5? And you got 1 and 3. And that's what LaShawn got too. 1 and 3 works for the first one. It does not seem to work for the second one. If it were -3, can you check your sign, LaShawn and Jaden? Would it be -3 by chance? No, that wouldn't work either. And what was your preferred method there? You graphed. And what did you do, LaShawn? You did a graph too? If you had a preferred method, take a look at these two in this system 1. X plus y equals 4, 2x minus y equals 5. What shows up and screams to you, ooh, do it this way, do it this way? Anything? Because you've got a y and a minus y right here. I would say the preferred method would be elimination, right? Because you have two opposites in the two equations. Yeah. Okay, let me just bring it up here. It's less than 10 minutes. Can you just wait? Because you have opposites in your two equations. So let's see if I can quickly figure out what this would be. So if I add these together, I get 3x is equal to 9. So that would mean x is equal to 3. And if x is equal to 3, then y is equal to 1. Did you say 3, 1 or 1, 3? Huh? You had 1, 3. If it's 3, 1, that works. That's kind of weird. All right, so let's take a look at the last set, system 3. This would be on page, well, I think it's on all 3 pages. We have 3x plus 2y equals 8, 5x minus 3y equals 7. I don't see that substitution would be the best. I don't see no opposites, not graphing. I mean, that doesn't stand out. Probably here. What kind of preferred method would you try to solve those two with? Just looking at them. Do you think it would be easy to graph these? No. How about substitution? No, because there's no y equals or x equals. Probably elimination again. Now, you'd have to do a little bit of multiplication because you don't have any opposites. But let's say I tried to get rid of the x's. I eliminate the x's. So if you got 3x and 5x, your least common denominator or least common multiple would be 15. So you might multiply the first one by 5 and multiply the second one. You want to get the opposite, which would be -15. If I do that, I'm going to get 10y is equal to 40, and 9y is equal to negative 21. That gives me 19y is equal to 19. So that gives me y is equal to 1. Oh, that one might be 1 and 3. Let's see. 1, 3 times 2 is 6, and 3. No, so it's not 3. 1 and 2. 1 and 2. 1 and 2. I don't know if that works, though. For the second equation, 5 minus 6 is not negative 7. So if y is equal to that, I'm sorry? Does it? 1. Y is equal to 1. Y is equal to 1. Y is equal to 1. So is it 2, 1? Okay. So 2 is 6, 7, 8, 10. Yes, 2, 1. Elimination because none of the others seem easy. Okay. All right. 53, 54. Okay. So I don't know how much work you actually did or were able to complete, but this just shows you which should be the easiest. And announcements for today, the next one is not going to be an assessment as a test. It will be a project. Okay? It will be a project. So, for some that's like, yay, others that's like, ooh. I will be here tonight after school and Wednesday after school. If you want to start on corrections and want to retake that, you have to have done all the homework. Okay? You have to have done all the homework. All right. Hopefully, maybe tomorrow, might kick Jemiah out and we can go over the tests a little bit. Okay? Oh, that's right. Jemiah and Nyla. We'll kick you both out. All right. Have a great rest of your day.